Okay, this chapter is about polynomials and rational functions, which covers for us, like from Algebra 2, that's like chapters 5, 6, and 9. Now, some of the vocabulary that they use here is a little different than what it was in Algebra 2. What's underneath it all is the same. There's no difference. But, for example, in Algebra 2, we didn't call this the definition of a quadratic function. We called it the standard form. Any polynomial, the standard form was highest degree term to the left, descending order of powers, no parentheses, right? In this book, they just call it the definition of a quadratic function. And what they call the standard form is something different. So why do you think they say that a does not equal 0? Is that going to lead to a divide by 0 or something like that? So why would a not equal 0? Charlotte? Because what kind of function would it be if a equals 0? It wouldn't be a quadratic anymore, would it? So it just says a doesn't equal 0 because if a is 0, you don't have a quadratic term, right? It's not that you can't, divide by 0 or anything. That's not a problem. Now, the good thing about this form of the quadratic function is that there's two things that you could tell just by looking at it, right? From the coefficient of x, right there, the a, you can tell whether or not this parabola, the shape of the graph, opens up or opens down. If a is greater than 0, this parabola will open up. If a is less than 0, then the parabola will open down. And the other thing you could tell is the constant term, the plus c, that's the y-intercept. Again, how do you find the y-intercept? Standard process. Substitute x equals 0. What happens if you substitute x equals 0 here and here? They're both 0 and the function equals the constant term, the c. So that's why the c is the y-intercept in this form.